Okay, so we have 2017 question C2 here. Alright, we're going to complete this here. This is a hyperbolic paraboloid. We have the parabola here, which is going to travel along the path of DBE. Okay, so that point B is always in contact with this parabola here. So we have two parabolas to start with, and we have DBE and we have ABC. Now, the question part A asks us to draw the plan view first, then the end view, and then the front elevation. And there is a part D as well, which I'll just be discussing a little bit later into the question. Okay, now the scale of this question is 1:5, so every measurement that you have must be divided by 5. So we have 700 there, we have two 700s, there's one 700, another one there. We actually have another one up here. What happens is when we divide that by 5, we end up getting a measurement of 140 millimeters, and everything needs to be divided by 5. So if you just shrink this down here, you'll see I've kind of started the question. Alright, so I have started off with the XY line, and I'm starting to set up the plan view currently. Alright, so the measurement from A to C here is 140 millimeters. Just so you can see that, I'll just mark in A and C in pen. Okay, we have our middle line here where we're going to get D and E. So again, I will mark off those measurements. We have a 700 to start with, and then we have 175 on either side. So 175 divided by 5 equals 35 millimeters. So I'll go an extra 35 on this side, and an extra 35 on this side. Okay, and then again, this is our point E, and this is our point D. In here in the middle, we have B. Okay, labeling is going to help an awful lot with this question as well, so make sure to include it wherever possible. Now, we're also going to take that 35 millimeters, and we're going to mark it in for the radius of this plan view. Same over here. Okay. And we are given the tangency points as well, which is 60 degrees from the center of this. There's our tangency point there. And the underside of it, there's our tangency point there. Doing it on the opposite side, we go 60 degrees. Tangency point there. Tangency point there. Now, we take our 30 degrees from that tangency point and draw it in. In both directions. Again, not too difficult at this stage, just following the drawing as it's given to us. Okay, now you'll also notice then on the drawing here that from the center we're coming out, and this is 90 degrees to that tangent, which is going to be parallel to what we originally did, which was 60 degrees. Okay, so if we take that point now and we go from the center through 60 degrees, we have that mark there. We go in the opposite direction doing the exact same thing. Again, remember accuracy here is key, good sharp pencil. Those lines are going to give us our radii. So setting up our compass on the very, very center point here, if we set it up to that measurement, or even to a measurement of A, this should match, and that will give us the curve at the top. Making sure that it's nice and visible. Okay, so that is part A of the question complete, and our plan view is finished. Okay, so now what we're going to do is we're going to move on to the end view, and what I'm going to do for this is I will use my 45 degree set square. I need it now in a second. If I bring it across all my points. set up our YY line here. So we're coming at an angle of 45 degrees from there. That'll help me draw in my parabola here in the end view. So I don't have to use any measurements. This should equal 700 automatically. Okay. And what we do is we just measure that to make sure this should be 140 millimeters, because used the wrong one. Lucky enough I checked that. So there we go there. Now there we have 140 millimeters, and that there is for your YY line. So always good to check, because mistakes can happen very easily. Now we take up point E to the ground point, we take up point D to the ground, and A and B are up as well. So looking at this, B, again we'll just enlarge this to see. Oh sorry, I have to do the end view here, apologies. So we'll do the end view here first, and B is going to be 150 millimeters off the ground. Divide that by 5, and we're talking 30 millimeters off the ground. So we have B, and then we have an extra 200, which is another 40 on top of that. So 200 divided by 5 is 40. So again, we're going to bring that with light pencil all the way across, because we're going to need them in both views. And again, the labeling is going to be key here in this. So this is point A and C. This here is, according to the question, point B, point A, and point C. And again, that matches up from our plan view, matches up from our plan view, matches up from our plan view. And what we're going to do now is we're going to use the divisional lines method, possibly, if we can't divide this into an even number. So we have 70 millimeters there and 40 millimeters there. Now what I like to do is I like to divide in either 4s or 5s. So the 40 millimeters is obviously a very, very easy number to divide into 4 segments. But the 70 millimeters, if we do that on our calculator, 70 divided by 4 equals 17 and a half, which isn't a good measurement. So what we're going to do is we're going to use the divisional lines method. So what we'll do is we draw our own line here. I'm just going to use a green pencil for this. Hopefully you can see the green in the visualizer. Okay, and on that line, it is our own line, we can do what we want with it. We can split that into 4 equal segments. So if I was to choose 15 millimeters as my measurement, there's 15, and another 15 is 30, and another 15 is 45, and another 15 is 60 millimeters. So we have 1, 2, 3, 4 segments. On my last point, I'll bring that to the halfway line. We'll introduce our second set square here. Hold that in place, slide along to create a parallel line, and that's going to give us a division here that we can use for our 70 millimeters, dividing our 70 millimeters by 4. And if you wanted to go then and measure it, it would end up at exactly 17 and a half. Okay, so we're using the divisional lines method there, that's key. Now, on this we have B, which is B is our vertex. And this point here, this line, is our axis. And that is our symmetry line. Okay, so it's going to be a mirror image. The parabola starts at A, lands at B, and then continues on to C. So, once we've identified the axis, we know that we have to draw lines parallel to the axis. So these lines, or these divisions here, are going to be parallel to the axis. 3, 2, and 1. Again, we'll number them. 3, 2, and 1. And again, as we get closer to B, this is going to be 3, 2, and 1. And these divisions on this side will end up going to the vertex. So we take 3, bring it to the vertex, where do the 2 3's cross? They cross there, giving us the point. Bring 2 to the vertex. Where do the 2's cross? They cross there. Bring 1 to the vertex. Where do the 2 1's cross? They cross there. What I like to do is I like to join them up with a pencil first, just to make sure I'm nice and accurate. And then I can trace over with a pen afterwards. Okay. And now what we're going to do is do the mirror image on this side. So we'll use our symmetry technique or our mirroring technique. It's taking our compass now from the center point or from the axis or the symmetry line. And rotating across. And again then, let me join these up. You can see already, I should have used pencil first. And yeah, there's our parabola. Nice and visible. Okay, now I'm going to get rid of this image now, because what we're going to do is we're not going to rely on it. We're going to use both views here to create our front elevation. The first thing that we're going to do for this front elevation is we're going to label in our points D, B, and E. And that is our parabola. So again, with our parabola, what we're going to be drawing is we're going to be drawing a rectangle. And with the rectangle, we can use the same method as we've used before in order to construct the parabola. And this time, it's a more regular parabola. The ball is traveling from G to B and landing on E again. So we have a measurement here of, let's just check, we have a measurement of 30 millimeters. 30 millimeters divided by 5, let's say, is 6 millimeters. And what we have here again is a measurement of 105. Divide that by 5, you get 21. Okay, so we don't actually have to use any divisional lines method here. If we go every 21, now again, good sharp pencil is really, really key here. Alright, making sure that we're deadly accurate with every point. I mark in the 5 divisions across here. The vertical divisions then can be split into 6 millimeters. So we go 6 and 12 and 18 and 24 and 30. Again, just making that nice and visible, making sure I get the marks from the examiner. Okay, now our axis again is here. This is our axis. When drawing a parabola, we need lines parallel to the axis, so therefore these lines are going to come vertically. And the ball is going to travel from D to B to E. So these lines are then going to go to a vertex. And B, again, just labeling it for demonstration purposes, is our vertex, which we're told in the question. Okay, which you're going to spend 5 minutes doing at the start of every exam, reading the question clearly so you know what you're being asked. Just going to double check that. So I have 1, 2, 3, 4, 5 divisions, 1, 2, 3, 4, 5, and ball starts here, so we can mark off 4, 3, 2, 1, 4, 3, 2, 1 as we're getting closer to B. So we're going to have this point, this point, this point, and this point. And again, let's sketch it in with a pencil first. pen. Again, similarly, we're going to do the symmetry technique. Don't bother doing that whole step again. We can bring all of this across horizontally using our compass. So we will, okay. Okay, so there's our parabola. Now, that's parts A, B, and almost C done. What we need to do is we need to finish off the upper part of this. Now, what we're going to do is we're going to vertically cut this plan view, okay, in sections. Now, we're only going to use one quadrant here. And what we are looking at here, when we look at our plan view, we are looking at different widths, a varying width measurement. So we're getting from narrow to wider, okay, and it goes from wider to narrow, and it's the same on the other side, a very, very symmetrical shape. If we look, the measurement from A, B to C is the same as a measurement A, B to C. So the width that is here is corresponding to a width here, and with that information we can know a height. That height then corresponds here. So the width information finds you a height, which you then use on your front elevation. Okay, so I actually have 1, 2, 3, 4 divisions here. What I'm going to do is I'm going to use those divisions and we're going to cut. Let's start off using divisions here in pencil. So these are my vertical cuts, vertical sections. Notice I'm only going halfway because it is a symmetrical shape. Now, the red lines are widths, and the blue lines, which you'll see in a second, are going to be heights. So this width, which I'm going to now take a measurement with my compass, this width measurement, if I use that width onto my drawing, the blue pencil line then is going to find me a height. So that width there corresponds to a height, and the height is always taken from B, the vertex, to where we need it, because the B is always traveling along this path. It's always the constant. So we're always measuring from B to the object, not from the base down. Okay, so this height is the information that I'm trying to find over here. So I'm going to use that height from the vertex. Now we can take the measurement. I often take the measurement from here. That's our height. And with cut 4, we're going to measure from the parabola here, the little hump or the roller coaster that the original parabola ABC is traveling along. It's going over that hill, and B is constantly in contact with here. Okay, so again, just so you can see that, I'm going to mark that in with a little black dot. Okay, now we're going to repeat the process with cut 3 here. I'm going to take width, we'll call this W1, with my compass from the center point, width 1, I'm going to apply width 1 here. There's width 1. Okay, and width 1, I draw this in blue. Wherever it cuts the parabola, That is height 1. So W1 equals H1. Okay, so now with that height 1, I'm going to take that measurement, again with my compass measuring tool, and on the vertical cut 3 from the parabola here, I mark it in, making it evident with a dot. We repeat this process over and over again, and we'll end up getting the front elevation solution. So we take vertical cut 2, giving us width 2. Take width 2 and measure that with the compass. Return over here, we mark it in, draw that cut, where does that cut? Again, that's H2. This here is W2. And whatever the height from, again, from the vertex, that height, H2, is going to be applied to the vertical section 2. We have H2 there. Marking that in a little bit heavier. And we've one more to go. We might even just do an additional one here just to make sure that we're getting our curve right. So we have the width of 3 through vertical section number 1. So just making sure you can see all this. So again, label that as W3. We take W3 with our compass. Bring it over to our parabola. Take that height. That is W3, giving us H3. And with H3, once I take that measurement, I can take it from anywhere. But H3 is then going to be applied onto the parabola there, giving us that point. Okay, and then we're going to join up our points. Again, we'll do this in pencil just first. Again, it's symmetrical shape, so I'm only worried about one side, and we can bring it to the other side. So we start off with D, which is 0. Come on to here. Now, that's our shape. To get that symmetrical, bring it across. that is A, B and C fully complete. Okay, now part D of the question. Which are asked for here. Okay. It has been decided to extend the surface of the canopy to provide more shade for the umpire. This will be achieved by extending the generating parabola ABC upwards and outwards as indicated by the arrows in the end view to a width of 900 millimeters. So we need the same parabola, but we now need to extend it till it is 100 or 200 millimeters wider, which is 900 millimeters in total. On a separate diagram, draw a new end view of the extended parabola. So what we're going to do is in this space down here, we're going to draw that. Okay, and again, what we can do is we can rub this out. Okay, so we're going to start with we can start with that as our point B. All right. This can be our point B. I just want to make sure that I have 900 millimeters. So 900 divided by 5 will be 180. Yeah, I'll have it up there. Okay. So if we pick this as our point B. Now, I'm going to use the exact same measurements and divisions here as I've done for this original one, because I have to draw that original one, except I'm going to continue them on, and then we're going to extend it out until we hit a 900 millimeter width. So we have to keep going with this and get our 900 millimeter width. Now it does say on a separate drawing, so you can't add it onto this, so you must do it separately. So what we had for the original one, we're going to set that up the exact same way. So again, lucky enough, I have my measurements here. I can bring them down, keep everything in sync. The height measurement from B to C was 40, so I can come up here from B by 40. I can bring this across. And this is our original A, and this is our original C. And what I'm going to use is I'm going to use the same divisions as I did in this question here. So if I take that division there, again, just to double check, that's 1. Just making sure you have it set up correctly. 2, 3, and 4. So I'm bang on there. If I measure this, go 1, 2, 3, and 4. Okay, and keeping that measurement, I'm just going to add 2 more here to the outside just for now. Okay. For the heights, if you recall what we used for the heights, I believe were, okay, so they were singular centimeters or 10 millimeters. So every 10 millimeters, there's 1, 2, 3, and 4. And what I'm going to do is, because we're going to have to go out beyond this point, I'm going to add on these extensions here as well. Just 2 more. All right. So we're first off going to work in this space here, and then going to extend it out until we hit 900. So again, this is our axis, so we're going to bring this down. Okay, we've done this already, so this really shouldn't take us too long. These points here will go to the vertex. Okay, and we have 1, 2, 3. We have our original parabola here. Again, that's only half, but we can mirror the other half in a second. And what we're looking for is we're looking to extend this on and continue this going until it hits our 900. So with these divisions here, these must go from the vertex through that division point and continue on from this vertex to that division point and continue on. Again, just to highlight this, I'm going to do this in blue so that you can see the new information. Vertex to that point, continue on. vertex to that new point and continue on. Alright, and with the divisions, same thing applies. This is a new line, so we continue that on there, and we continue that on there. So wherever they hit, again, gives us a point, because what we did was, if this was division 1, 2, 3, 4, 5, and 6, as we're moving up this way, this is division 1, 2, 3, 4, 5, and 6. So where 1 met 1, we had a point. Where 2 met 2, we had a point. Where 3 met 3, we had a point. 4 met 4, where does 5 meet 5? Meets it here. Where does 6 meet 6? 6 meets 6. There. Okay, that would be our parabola. Now, all we need is, we need 900. We divide 900 by 5, and we get 1800. Oh, apologies, 180 millimeters. So dividing that by 2, you get 90. So if I come out as far as 90, that's my halfway point. If I cut off that parabola, that's my cutoff point. Okay, and we go to the other side, the exact same cutoff point here. So we draw on this parabola, joining up all of our points. 6 to 5 to 4, and that is no problem. I'm going to mirror that across. So we bring 1 across, 2, 3, 4. We don't have to because we already have it. 5 is here. And 6, which we'll probably run out of page for, but not to worry. So I then take my compass. I take the measurement of 1. Where's point 1? It's there. Mirror it across. The measurement of point 2. Mirror that across. The measurement of point 3. Mirror that across. Measurement of point 4 is already done, so I only do a measurement of 5. Mirrored across, and the measurement of 6. Again, mirrored across, which we don't need running out of page. And what I'm going to do as well is I'm going to draw in my big line here to cut it off at the 900. So that there is cutting it off. Bring that across. Here's my measurement for 900 on the other side, which again, we'll cut it off. And joining them up, that is our parabola, which is extended to the new 900 millimeter width. Like so. Okay, that's our new parabola, and that's how that's done. So hopefully that helps. If not, leave a message on the video or email me. Thank you.